Okay, welcome to, I think this is video 7 if I'm keeping count properly. We are almost done. Almost done. Okay, the figure gives a circle of a radius 4.8 in the xy plane with the center at the origin. Bam. Um, an angle alpha in center position and 3 labeled points. What's the following value of sine A? So looking at this, since this is a radius of 5, the value of sine of A should be, so this is what, 2.2, 4.3. So 4.3, let's do it this way. This point right here is going to be r cosine theta, comma, r sine theta. So if we want the value of sine theta, we know that r sine theta is equal to our y value, which is 4.3. And we know the radius is 5, so 5 sine theta is equal to 4.3. To find the value of sine theta, we need to get sine by itself, divide both sides by 5, and we should get sine theta is equal to 4.3 over 5, which is not on here. Did I do something wrong? Let's see. What is 4.3 divided by 5 is 0.86. Oh, I did something wrong. R sine theta what are the following values of sine theta? Sorry, I keep saying theta alpha. Doesn't really matter, but should say alpha. Sine is 4.3. Oh, it's because I didn't read. Radius is 4.8. So this should be 4.8. So this should be 4.3 over 4.8, which is B. There we go. See, just have to read and not just look at pictures. It was pretty close to 5, but it wasn't actually 5. Um, Starting to rush. Okay, 37. In the xy plane, angle BAC is in standard position with a terminal ray AC, which intersects the unit circle. Okay, so we got this whole sketch again. There is our unit circle, and this is a BAC standard position. And it intersects the point at coordinates 0.4 and negative 0.9. So 0.4 and negative 0.9. So that's positive and negative. So somewhere right here. So this is C. This point right here would be B. And this point right here would be A. And this is our angle in standard position. Right there. Which of the following descriptions is correct? The tangent of BAC is negative 4/9. So the tangent is x over y, or y over x. So it's going to be 0.9, negative 0.9 over 0.4, which this does simplify to negative 9/4, which is not what this is. So that is going to be y over x. That's not what this one is either. Okay, so it's both of these. So it's C or D. And the slope of the ray of AC is negative 9/4. Yeah, the slope is the same as the tangent, so it will be C. 38. An angle theta is in standard position in the xy plane. Which of the following is true about theta on the interval from 0 to 2 pi if tangent of theta is 1? So it's in standard position on the plane. So if you look at this, we have standard position on the XY plane. Draw our circle again. So tangent of 1. So this is a positive number. Positive number should tell us that we are in quadrants 1 or quadrant 3. So either, and 1 is going to be pi over 4. So it's going to be pi over 4, or it's going to be 5 pi over 4 down here. So it's got to be one of these two angles if it's 1. So let's see here. The value of theta on 0 to 2 pi is 1. Oh, so here's the quadrants. Awesome. Quadrant 1 only. Nope. Quadrant 1 and 3 is only. Yeah, that looks right. Quadrant is 1 in all 4. Nope, because it's negative here. It's negative in quadrants 2 and 4. And there's no value where it is 1. Nope, it's definitely 1 right here. So it must be B. Okay, number 39. Number 39. The figure shows the unit circle in XY plane and an angle alpha in standard position. Awesome. And 3 labeled points, B, O, and A. Which of the following is the value of cosine? So this has a unit circle of 1. Cosine is just, this is r cosine theta, comma, r sine theta is the point. Any point on the circle is this right here. The radius is 1, so we actually don't need r. So it's just cosine theta, sine theta. And cosine is the x value, so it should just be negative 0.8. And then this one, when you board a Ferris wheel, your feet are 1 foot off the ground at the highest. So we have a Ferris wheel. And our feet are 1 foot off the ground when we board. At the highest point of the ride, we are at 99 feet. Bam, 99 feet. It takes 30 seconds for the ride to complete 1 full circle. Write a trig equation for your height above the ground at t seconds after the ride starts. And you got to find A, B, and D to write an equation, and using a sine that models the movement of the ride. This should say sinusoidal, so we'll use cosine. It's given us cosine right now, so we will use that. So in order to find, we need A, B, C, and D. Well, A is our amplitude, which is max minus minimum divided by 2. So our max is 99 feet. Our minimum is 1 foot, so 99 to 1. So that should give us an amplitude of 98 divided by 2, or 49. So 49. Because we're boarding at the bottom, we're going to make this a negative 49. For B, B is our period divided by 2 pi divided by our period. So this is 2 pi over period, which is 2 pi over, what was our period, 30 seconds? Yeah, that is terrifyingly fast. So that should be pi over 15. I highly, highly suggest nobody get on this Ferris wheel. I mean, the circumference of this thing. Oh man, that is terrifying. If the radius is 49, that makes the circumference almost 300. So you're going 300 feet every 100 feet per second. Ugh, that is fast. Don't get on that. C, we're just going to use negative cosine, so we don't need C. And then finally, we need our D, which is max plus minimum divided by 2. So it is 99 plus 1 divided by 2, which is 50. Bam. And there we go. Again, amplitude, midline. These are the keys. R cosine theta, R sine theta. These will get you through most of the tests. And just to reiterate, don't get on this Ferris wheel. That is terrifying. I hope y'all have. Hope these help. I hope you enjoy them. And email me with any questions. Y'all have a great rest of your weekend.